When can we take the quiz? It's open. I sent an email to you because some people had trouble with the quiz. I had the wrong date on the quiz, and a couple of people, thank you for getting back to me, and I tried to fix it. Some of you, a couple of you said they see the new date at the 15th, and a couple of you don't. So originally it was due yesterday, which I was totally wrong. So I made it the 15th. You can take the quiz anytime you want from now. We still have a good amount to look at. So I don't know if I would take it quite yet until release, maybe after today, if you want to try it. You have 2 chances. So you can take it, when you feel you're ready. And then if you don't like that result, you can take it again. But it's due to 15th. All the homework is due to 15th. The quiz is due to 15th, and then the test is the 16th. That's a question I had up here, so I want to answer that. Okay, so sort of kind of review of what we did. So I just want to do a little bit more. So first I want to do combining like terms again. Combining like terms. We did a little bit on Tuesday, but I want to do a little bit more today. So, one. Oh wait, hold on, someone's just coming. Okay, so combine like terms means putting together the same variable and exponent terms together. So I'm going to start real small. So 8m plus 14m. If you notice, they both have an m. That means they're both like terms, and the m is just an m. So I'm just going to add the coefficients. I'm going to add the numbers. So 8 plus 14 is 22. So I have 22m. You can think of it as I have 8 m's, and I'm adding 14 more m's. Sort of kind of what it means. I have 8 m's, I'm adding 14 more m's. So in total, I have 22m. Hold on 1 second. I got to turn off my emails. I'm getting like tons of emails, and it keeps beeping in my ear. Yeah. Good. Usually I keep it turned off. Okay. Okay, hold on. Let's see. Let's stop screen share. I'm gonna start again. You guys see it all? There it is. Okay. Here's my screen. Okay, second. 12x minus 8x. So they're both x, so I can combine them together. So 12 minus 8, 4. So I have 4x. So I had 12 x's, and I'm taking 8 of them away. I have 4x left. Three. Negative y squared plus 3y squared plus 7. Now this time we have y squares, and we have a 7, which is not part of the same like term. They're not like terms. But also, when you see a negative y squared or y squared by itself, I'll put it over here. If you see something like a negative y squared or y squared by itself, there is an implied 1 in the front. So when you see negative y squared, it's really negative 1y squared. That's what I want you to think. It means there's 1 of them. So negative 1y squared plus 3y squared, that would make 3 minus 1 is 2, 2y squares plus 7, because 7 does not have a y squared, so it is not a like term, you can't combine them. A plus 3a minus A. Okay, again, the A by itself, that just means that there's one of them. And feel free to put a 1 in front. They're never going to give you the 1, but you can write the 1 in to remind you. So I have 6A plus 3A, 6 plus 3, that's 9. I take 1 away, and that would be AA. Any questions so far? Ask away. I see it's cat day again, I see. Love it.
Garrett, I have a quick question.
Go ahead, go for it.
I think I remember on homework, like, what if there's a 1y squared plus 1y squared or something like that, and they cancel each other out?
Yeah, so if you had y squared minus y squared, which is beautiful, let's put a quick question because it'd be 1 of each, right? That's just saying like 1 minus 1, which that just means they cancel each other out. So it just would be 0. And then let's say you had y squared plus y squared. And that's like saying I have 1 y squared and I'm adding another y squared. That means I have actually 2 of them, 2 y squares. It's a great question. Did I answer your question all right?
Yes, thank you.
You're welcome.
So would it just be 0 or would it be 0 y squared?
Great question too. Okay, technically it's 0 y squared, but that's not simplified because what's 0 times anything? 0.
Yeah,
So
0.
right. So it is 0 y squared. It means you had 0 y squareds left, right? So it's just 0. Because 0 times anything is 0. That's a great question too. I got a couple chat questions, I think, maybe. Hold on. Oh, you guys are good. Perfect. Okay, 6. 5 minus 2D plus 3 minus 5D. All right, so we have definitely 2 different things. We have D's and we have not D's. And if you remember standard form, that the exponents come first. And I need to go look at your test and see if they have standard form on it. I'm gonna do that before we leave. Actually, I know if it does or not. Hold on. I actually printed it out right in front of me. The same standard form. I do not see standard form, so I don't think standard form's in the test. It's going to be in a test coming up, but it's not in a test. So if you forget standard form for now, perfect. It's all right. Standard form just means the highest exponent to the lowest exponent. So I look here. I'm going to do the D's first because they have an exponent of 1. So negative 2D and negative 5D. Okay, so negative 2 plus negative 5 is negative 7, negative 7D. Negative 7D. And then I'm going to look at my non-Ds, which are 5 and positive 3. Notice how I circled that plus 3. You always want to look at the sign before. So 5 plus 3 is 8. Negative 7D plus 8. Okay, so now I'm gonna get a little bit longer. Slow to get there. I'm gonna turn the page. Anybody need more time before I turn the page? I'm looking at you. You gotta look, you're all right. Okay, 7. Negative 7y minus 5. Do you see how I keep changing the variables too? One thing about algebra is they don't use x. They'll use x for a while, and then they start making all different kind of variables. So especially problems like this, because you have to combine like terms. So they're going to use more than one variable if it's long like this. All right, so if you look real briefly, like right through it, you'll see 3 things. I see y's, I see x's, and I see numbers. Oh, another cat. Oh, it's cat day again. That's so cute. All right, so we're gonna look at, it doesn't matter which one we do first, X or Y, at least right now. So let's do the Y's first. Because none of them have an exponent, they're all without an exponent. So -7, now look at the negative in front and the positive in front. So -7 plus 2. Okay, so that means we're going to subtract them. -7 plus 2, which means it's 7 minus 2, which is 5. But 7's the bigger number, that's negative, -5y. They're done. Now let's look at the x's. I'll underline them twice. Actually, I'm going to circle them too, because I want you to see that we have to think of it as a positive 9x and a negative y, or minus y. So 9 minus x, I said y, I meant x, 9x and negative x. So what we do know is that there is a 1 in front of my x. So they're like terms. 9 minus 1 is 8, and that means I have 8 x's. Positive because 9's bigger and 9's positive. And then lastly, I do my numbers. I'm going to change my color because I want this to stand out. So -5 and 12. So -5 plus 12, they're different signs. I subtract them. 12 minus 5 is 7. 12 is positive. That's a bigger number. So it would be plus 7. So there were 3 different like terms. We had y's, we had x's, and we had our coefficients, our constants, our numbers without variables. How's that one? We good? I know it gets confusing, but it's all right. One thing about me I never told you is like I like to give the harder questions in class so that when you take your test, it's like super easy. So looking at your test, problems are really on the easier side, which makes me happy, which is the whole idea. If I do the harder problems with you, then when you take your test, it's easy. And then as we get going on, you're that much ready for it. Okay, so now we're going to shift gears a little bit. We're going to simplify. We still have to combine like terms, but we might have to do something else first. And I'll show you what I mean. Okay, simplify. We're going to start small though. -10 times 2y. You can rewrite it if you don't like the parentheses. -10 times 2y. That's all it means. -10 times 2y. So we're going to multiply our numbers. -10 times 2, -20y. Now, we have been adding and subtracting like terms, right? Now we switch to multiplying. We're going to have multiplying and adding and subtracting. When you multiply the numbers, but you keep your variable. It's not like adding, but they both have to have y. You just multiply your numbers and the y stays, or whatever variable it is stays. Do have to think about your negative sign. So negative times a positive was a negative. Try this one. 4 times 3x. Yes, you're going to see parentheses a lot for multiply. Plus 6 times 2x minus 4. And Maddie, this is when we were talking about last class, when you said like x squared. When you start multiplying 2 x's, that's when it becomes squared. We're not getting there yet. We're just keeping it not squared. But that's when you're going to start seeing squares and stuff like that. But we're not there yet.
Gotcha. So is that only when you multiply?
Yeah, the exponents change only when you multiply. And we'll get to that section coming up, but we're not there yet. I just wanted to let you know, this is a concept you were thinking about. All right, so now we're going to multiply the first term. 4 times 3 is 12x plus 6 times 2, 12x minus 4. So once I multiply, then I'm going to combine like terms. So This is my like term, and this is my like term. So I can then add my like term. So multiply, and then you're adding like and subtracting like terms. So 12 plus 12 is 24x. That's my like terms, minus 4. It's the only constant I have, the only number we have without a variable, so minus 4. And I want to do one more before I turn this page, and this one's an important one. Okay, this is also a lot in algebra. I'm going to add something underneath it. This is a property. We did this once already, but we didn't do it like this. We only touched upon it briefly a while ago. Distributed property. Algebra has a lot of distributed property. And what that means, you'll have a number or something in the front that you're going to multiply through something that's added or subtracted. So when that happens, I'm going to write it down here. You have to take 8 and multiply to everything on the inside. So 8 will multiply to everything inside the parentheses. So if I have, I don't know, 10 things in that parentheses, 8 goes to everything. We only have 2. So a lot of times we want to think of this way. We're going to multiply 8 times x. 8 times x, it means 8x. Remember that there's a 1. Let me change this color again. There's a 1 in front of my x. So 8 times 1 is just 8. And there are x's, 8 x's. And then you're going to multiply 8 times 2. 8 times 2, 8 and 8 is 16. And my answer is 16. So whenever you have a number, or it could be a variable too, outside of parentheses, it's called distributed property when you have adding or subtracting, and you have to multiply to every single thing on the inside. Okay? We're gonna do another one. I'm gonna turn my page. Anybody need more time? Everybody keeping up to me? Everybody good? Yeah, good. I see shaking heads, good. Okay, so that was number 10. Okay, number 11. Same idea, just looks a little different. -4 times 2y minus 1. Again, it's just distributed property. It's you'll get used to seeing it and going, oh yeah, it's distributed property, because it has parentheses, it has adding and subtracting inside of parentheses, and it has something on the outside. So we're going to multiply. -4 gets multiplied to every single thing on the inside. So -4 times 2y. Well, -4 times 2 is -8, and there's y. So -8y. And then be very, very, very careful with this. This is not -4 times 1. This is -4 times -1, because you take the sign in front. A negative is a minus. So -4 times -1 is going to be +4. So you got to think of it this way. It's -4 times -1, or -4 times -1, and negative times negative is a positive, and that's how we got +4. We're going to do a few of these because they're important. 12. Six parentheses, -3y plus 5. By the way, notice we haven't combined like terms because each of them had a variable term and a non-variable term. So there's nothing to add. And same idea here. I have a number in the front and I have parentheses, but adding inside. So I'm going to do distributed property. So 6 times -3, that's -18. And I have a y. 6 times +5 is 30 plus 30. Okay, so like I said, we haven't combined like terms yet. We haven't had anything to combine. So I'm going to add a couple little things to combine just so you can see what it's like. We have a little bit more to do. So 13, 5 parentheses, 2p minus 3 minus 8. So now we have a little bit more, added a number on the outside, minus 8. Now you are only allowed to multiply that 5 to anything inside the parentheses. So 5 is not multiplied by -8. That's very different. This is the only thing I'm distributing right here inside the parentheses. Think of the parentheses as, well, actually, let me write this down. Think of the parentheses as, this is where I start multiplying my 5, and this is where I stop multiplying my 5. Start and stop. It tells you where to start multiplying it and tells you when to stop multiplying it. So I'm going to do 5 times 2. That's inside my parentheses. That's where I start. 5 times 2p is 10p. 5 times, now remember it's a -3. So 5 times -3 is -15. And then I'm done multiplying. And in my parentheses, I'm done multiplying the 5. And I just bring down the -8. Now we have more work to do because I have 1p, beautiful. I have no more p's to do, but I have these 2 numbers I can put together. They're like terms. So -15 minus 8, they're the same sign. I'm going to add them. So 15 plus 8 is 23. So it'd be -23 because they both are negative. So we keep the sign. I just add wrong. 23. I'm gonna stop there for a minute. Any questions? I'm gonna do a few more of these and then we're gonna want to go on to one more thing and then go to the next section. We're okay so far? Yeah, okay. And anybody who's having trouble, I know a few people have mentioned to me they're having trouble with this section. It is getting harder, and I understand that's how it gets, so kind of. But I'm here after class, so if you want to sit with me, we can sit and do problems together. Stay after class and sit with me, and we do whatever you need. We'll practice and practice and practice. So then I am on this one. -7 parentheses, x minus 1. I'm actually gonna put a 1 here because I got too close. Plus 5 parentheses, 2x plus 3. So now we have 2 things we're multiplying. So -7 goes to the first parentheses and 5 gets multiplied by the second parentheses. So we're going to distribute the -7 to the x. -7 times x, which I keep doing this in case you need it, which just means 1x, right? So -7 times 1x is -7x. And -7 times a -1, you gotta take that sign with it, is +7. Just remember, this means -7 times -1 for this one, which is 7. And then we're going to go to our next parentheses, but bring down the sign, plus 5. Whoops, I just erased my plus 5. Okay, so I shouldn't really say bring down the sign. Hold on a second. Actually, I'm going to do it. I am going to write it down. I'm just writing it down. Then we're going to do the next. I don't want to do it all one step. I'm going to do a second, different steps. So -7x plus 7. Now we're going to distribute +5 times 2x. That's +10x. And +5 times +3, which is +15. You could do it one step. As I'm sitting here, I'm thinking I just want to do it in 2 steps. So I did the first parentheses, wrote it all down, and then the second parentheses, wrote it all down. And now you will see that we have 2 different things to combine. We have x's and we have non-x's. So -7 plus 10 They're opposite signs, -7 and 10. So I'm going to subtract them. 10 minus 7 is 3. 10 is my bigger number, so it's +3, and I have an x. So +3x. And then I can combine my numbers, my constants. 7 plus 15, they're both positive, so I'm going to add them, which is 22. Negative, parentheses, c minus 4 plus 2c plus 3. And we have 1 parentheses. Now this one looks different because it's not a number, just a negative in the front. So we're not distributing a number throughout the parentheses. We're distributing a negative. But it's not really a negative, although it is a negative, it's really a -1. We just don't put the 1, we just put negative. So if I do -1 times c, that's -1c. If I do negative times a -4, notice that's a -4, right? -1 times a -4 is a +4. And now I'm going to bring down my 2c plus 3 because I have nothing to do with that. I don't have to multiply or anything. And now we're going to combine our like terms. So we have c's and non-c's. If I look at my c's, I have a -1c plus 2c, opposite signs. So I want to subtract them. 2 minus 1 is 1, but 2 is bigger and it's positive, so it's 1c. And then our numbers, 4 plus 3 is 7. Now, in algebra, you will never see 1c. You will see c plus 7. We don't write 1 in algebra. We just like implied 1. So you'll see it as written c plus 7. If you enter it into MATLAB as 1c plus 7, they will mark it wrong. It's still right. But in algebra, we don't write the 1 in front. If you need to put the 1 in front for now, put the 1 in front. It's fine. Eventually, we'll do without the 1. Okay, questions? I think I have one more I want to show you. Last one. X minus 3, parentheses, 5x minus 7. All right, so we have to look at this. It's like written sort of kind of like in a weird way. But if we look at it right, we're fine. So this x in the front has nothing to do with that parentheses. It's just sitting there, right? So we're just going to bring it down. We're not multiplying it. It's just sitting in the front. That has nothing to do with multiplying. The only thing we're multiplying is this. -3 times the parentheses. X is very separate. So x is just going to stay. So we're going to take -3 and we're going to multiply it by the 5x and -3 by the -7. But that x has nothing to do with multiplying, that's separate. So we are going to multiply -3 times 5x. So -3 times 5 is -15 with an x, -15x. And then we're going to take -3 and we're going to multiply it by -7. Remember to take the sign in the front. And remember, the minus is negative, right? So -3 times -7 is +21. And then when I combine like terms, we're going to remember that this just means a 1. So 1x minus 15, they're opposite signs. I'm going to subtract them. 15 minus 1 is 14. But my bigger number is 15, which is negative. So it's -14x plus 21. Okay. One more thing to add. And we're going to actually put this into something that we talked about already. We're going to talk about area and perimeter. Actually, no, not area yet. I'm not ready for area, perimeter. And let me turn my page. It's exactly the same, it just went for kind of like a geometry way, put that way. So I'm finding perimeter. Whoops, let me get back to black. And just to remind you, perimeter is when we add all the sides of the figure. What I mean by a figure, like a triangle, rectangle, a hexagon, any kind of geometry figure. Okay, so we're going to find the perimeter. So find the perimeter. I'm going to do two problems. One. Okay, so this is a square. I know it doesn't look like a square, but it's a square. So square. One thing I can't do is draw. I'm awful at drawing. So it's a square. What we know about a square? All sides are equal, right? If you have a square all the way around, if I tell you one side's 2, all the sides are 2, right? So one side is 6x. If I want to know the perimeter, I have to add all 4 sides, right? So technically, if I know one side is 6x, I know all the sides are 6x because it's a square. I don't have to tell you that because I tell you it's a square and you're supposed to know they're all the same. So 2 ways you can think of this problem. You can find the perimeter by going, okay, it's 6x plus, so adding all the way around, I'm adding all the way around, 6, doing that one, plus that one, plus that one, plus that one. So I have my 4 sides added together, and then for combined like terms are all x's. So 6 plus 6 plus 6 plus 6, 12, 24x. That's one way to do it. Or you could go, okay, there's 4 sides and they're all the same. So 4, 6x's. And that means I have 24x. Whichever way it is you think of it as, it's 24x. I like to think of adding all the way around because that's how you do all perimeters, but there's definitely 4 of them, you can multiply them. And the last one would be a triangle. So I have 8p from one side, I have 4p for the other side, and I have 11p for the last side. So if I want to know the perimeter, now, of course, we're not finding a number answer, we're finding an algebraic expression, which again makes it feel weird. You feel like perimeter should be a number. It doesn't have to be a number, and I'll show you why. So if we want to find the perimeter, we're going to add all the sides. So we have 8p plus 4p plus 11p. Right, so we're going to add them up. I'll do one at a time, order of operations, right? 8 plus 4, that's 12p plus 11p. And now I can put them together, and 12 plus 11 would be 23p. Now, this is where your algebra comes in. So this is an expression. Why would you want to know a perimeter with a variable? Well, because this is an expression. So now I could say easily, okay, find the perimeter when P is equal to 5. And that's what we've been working on before. We sort of did them separately, never putting them together. So now I have this expression. My expression is 23p, but I want to know the perimeter when P is 5. So that means I'm substituting, right? So 23 times 5. And then I can multiply them to 23 times 5. 5 times 3 is 15. 5 times 2 is 10 plus 1 is 11. And my perimeter now, I have a actually number for my perimeter, 115. Whether it's centimeters, inches, we don't know, but it's 115 or whatever the unit is. And I could do that for forever. Find the perimeter when P is 2. Find the perimeter when P is 40. So it's just an expression for your perimeter. And then I can give you any P value. You can tell me the value of that perimeter. Okay, how are we? That was a big section. That was a lot. Okay. The big thing to remember is that when you add and subtract, you're combining like terms. So they have to be the same. Like they have to have the same X, they have to be the same number, they have to be the same. So X's go together or any variable and numbers go together, right? And they can't be combined. When you multiply though, you're multiplying your coefficients, you're multiplying your numbers and you're keeping the variable. So that can be a little confusing going back and forth between adding, subtracting, and multiplying. So now, there's a big drum roll. We're going to start solving equations, algebraic equations. So we're going into, I'm going to put these together because really 2, 6 and 3, 2 are the same exact topic. It's just 2, 6 starts small and 3, 2 just brings that a little bit bigger. I got a couple. Hold on. I got a couple. Let's see. Okay, so Angel asks, can you do a problem where 2 numbers are in front of the parentheses? 2 numbers from the parentheses. You could, they wouldn't be, the only way that would happen and it would be something like, so this is a side note for a second. 3 plus 4 parentheses 2x minus 3, for instance. Or you could have 3 times, well, actually I'm gonna write down here so I do both of them. Right here. Or you could have 3 times 4 parentheses 2x minus 3. That's interesting. Okay, so then this first one, there's this plus sign, right? So it keeps them separate. So this plus sign means I'm going to do order of operations. I'm going to do parentheses and multiplying first. I'm going to do that part first. There's nothing inside the parentheses I can combine because they're not like terms. So I'm going to do my distributive property first. And that 3 is going to hang out in the front. So 4 times 2, that's 8x. 4 times negative 3 is negative 12, and then I would combine my like terms. So I have 8x, that's the only x I have, and then I have my like terms of 3 and negative 12. 12 minus 3 is 9, but the 12 is bigger and it's negative 9. Or you can have multiplying. You could have actually multiplying. So again, we still have to follow order of operations, which means we have to do parentheses first, but there's nothing to do in the parentheses. We just have all multiplying. So technically we have 3 times 4 times 2x minus 3. So we can, by order of operations, we're going to do multiplying. So we're going to do 3 times 4 is 12, parentheses 2x minus 3. And then we're going to do our distributing. So now we have our number in front of our parentheses with a subtract sign, and now we're going to just distribute. 12 times 2, 24x. 12 times negative 3, make sure you use that negative 3. 12 times 3 is 36, but it's negative 36. So that would be an example of 2 numbers in front of the x. But don't worry about that yet, because we're not there yet. It's coming with the 2 numbers in front of x. Oh, there was some like that in the homework. Interesting. Just like the one I just did. I didn't remember that. Awesome. Does that make sense? So if you have numbers in front. Now I also want to show you something now that we've been talking about it. Go back to this one for a minute. I could rewrite it. If you don't like the way it's written, you can rewrite it. Meaning I could go like this. I could rearrange it. Do my x in front because adding is commutative. I can move things around. we're just have adding and subtracting. We don't have multiplying. There's no order of operation. There is order of operations, but we can combine, we can put the like terms together. So 8x, I can do minus 12, and I can take that 3 and put it in the back. So it looks a little better. And now I can do 8x, 12, negative 12 plus 3. That would be your 9, but it's negative 9, and I have my answer. So if you don't like it in the front, you could move it to the back as a plus 3. Just have to be careful to remember that's a positive, so it has to be a plus. Do you hear dogs barking? If you do, I'm sorry. They're barking. Someone's at my door. They don't like it. Okay, so awesome. Okay, now 2,6, I call it 2,6/3,2. So we just finished 3,1. This is our last 2 sections. So we are going to be solving algebraic equations. The first thing to think about is, what does solving mean? Right, so we just finished combining like terms or simplifying. So now we're switching from simplifying to solving. So within solving, you probably have to simplify part of an equation. So it sort of kind of goes hand in hand. We practice simplifying so we can solve. So what does solve mean? Solve means that you will find a value for your variable. When we simplify, we still have our variable, like 4x minus 2. We don't have like a number answer. We have an expression answer. Now we're going to have a number answer, which means at the end of solving, you're going to have something like this. X is equal to 12. C is equal to negative 4. You're actually going to get a number answer. So we're solving to find what X is equal to, what C is equal to, whatever the variable is. We are finding what our variable is equal to. That's what we're doing. So solving says we are solving, we're finding what our variable is equal to. So it's going to be a numerical answer. It's going to be a number. And remember, we have expressions and equations we talked about last time. So an expression, which we've been working with, is something like 4x plus 3. That's your expression. When we simplified the last section, that's what we got. We got expressions. Now we're going to get something like, we're going to be given something like 4x plus 3 equals 5. That's your equation. When you have an equation like this, you're going to get a number answer. So at the end, we're going to find that X is equal to some number, whatever that is. And that's what we're going to practice, how to find that number. So that's what we're doing today. How do we find that number? That's what we're going to do with solving. So solving to find that number. What is that number?
It's Garrett. Can you scroll back up just a little bit?
Yeah, does everybody have this bottom all right? Yeah. How's that? 4? That's the beginning, right? So simplifying expressions, we're going to have an expression answer. Solving an equation, we're going to have a number answer. So without an equal sign, you get an expression. With the equal sign, you get a number. Having trouble hearing a little bit, guys. Let me know if you're having trouble with that. I don't know. right next to my Wi-Fi like I usually am. I don't know why. It's nice outside. I don't see the storms or anything. I don't know. All right, so we good? We all caught up? We're gonna warm up by doing something first, and then we're gonna start looking at how do we solve an equation. Okay, so. Okay, this is our warm up to get us ready. Warm up. Determine whether -2 is a solution of the equation, which means I'm going to have it equal to 3x minus 2 is equal to 4. It's not a question. Statement. Determine whether -2 is a solution of the equation 3x minus 2 is equal to 4. Okay, so how do we know when something's a solution or when it's not? Well, when it says solution, it's saying, this other way to say this question is x equal -2 correct? Is that what's going to make this true? That's what it's saying. So what determine whether -2 is a solution of the equation means that we're going to plug in -2, substitute. So we're going to take our 3, so we're going to take x out, and we're going to put -2 in. And we're going to simplify this and find out, does this equal 2, 4? If it is, the answer is yes, it's a solution. If it doesn't equal 4, the answer is no, it's not a solution. So one more time. So if it's asking you whether a numerical value is a solution, you're taking that number they give you, you're plugging into your variable, whatever the variable may be, and you're finding out, does it equal what it says it's supposed to equal? So if I go here and I go, let me write it again. Let's simplify. So -3 times -2 is -6 minus 2. I don't even have to finish it, but I will, because that's not going to be equal to 4. -2, -6 minus 2, they're the same sign, so I add them. 8, and they're both negative. -8 does not equal 4. So no, -2 is not a solution. In order to be a solution, it has to equal whatever it's telling you it's equal to. So in our instance, let's say it asked you this. Is -2 a solution of 3x minus 2 equals -8? The answer would be yes. But we just saw that it equals -8. But it definitely is not for 4. Not equal to 4. Let's try a different one. Is -3 a solution of the equation 9x minus 1 equals -28? Question mark. What do I need to do? I need to take -3. I need to replace x with -3 and see if they happen to be equal. So 9, I take x out and I'll put -3 in, minus 1. Okay, order of operations, I got to multiply first. So I don't know why I put that there if I don't like it. 9 times -3, that would be -27 minus 1. Negative 27 minus 1, that's the same sign, so I'm going to add them. 27 plus 1 is 28. They're both negative, so is negative 28. Is negative 28 equal to negative 28? Yes. So negative 3 is a solution. Why did we start there? Because one thing about solving equation, which I really love, is that you can check your answer. Once you solve an equation, you can plug it in like we just did, and we can see if we're actually right or wrong. So you can find out if you made a mistake or not. And I'll show you that as we go on, because we're always going to check our solution, always.
Someone
is how you
said
check
that
the
it don't make sense.
Say again.
Someone said that it didn't make no sense.
Someone said it doesn't make sense. That does make sense. I say it does make sense, but I don't know. I see it does make sense. You don't think it makes sense? If so, ask me a question. I'll explain it why. Anybody have any question? I'll explain it. I can do another one if you want.
My mistake. My mistake. I didn't read it. It said someone said that it does make sense. My bad.
Yeah, it's all right. It's all right. It's all right. That's fine. I'm glad. I'm not really paying attention to chat that much. Okay, good. Okay, so I'm changing the page. I'm adding a page.